in this problem, we will calculate those two sums using the technique of telescoping. So what is telescoping? Is to write the term of a sum as a difference of two consecutive terms in a sequence. Here I will start with the first one. So the first one has the term like this: 1 over n times n plus 1. So every term here, 1 times 2, has this form, n times n plus 1. So here it's equal to 1 plus n minus n over n times n plus 1, which is of course equal to, here we will separate, it's 1 plus n over n times n plus 1 minus n over n times n plus 1. And here you see those two terms cancel, 1 plus n here cancel, so it's equal to 1 over n minus, and here n will cancel, 1 over n plus 1. So every term here has this form, 1 over n minus 1 over n plus 1. Oh, let's start with the first, with n equals 1. It's 1 over 1 minus 1 over 2. For the second one, the same rule, plus 1 over 2 minus 1 over 3. And the third one, 1 over 3 minus 1 over 4. And continuing until here, 1 over 98 minus 1 over 99 plus 1 over 99 minus 1 over 100. And here you see that the terms in the middle all will cancel. Here minus 1/2 with plus 1/2, minus 1/3 with plus 1/3, and continuing until here. Those will cancel. Also this one will cancel with the previous one. So the remaining is just 1 minus 1 over 100. And of course it's equal to 100 minus 1 over 100, which is equal to 99 over 100. Now let's calculate the second one. In the second one, the term has the form of 1 over square root of n plus square root of n plus 1, which is of course equal to 1 over square root of n plus 1 plus square root of n. Now let's multiply by the conjugate. The conjugate of this number is just, so square root of n plus 1 plus square root of n. Its conjugate is square root of n plus 1 minus square root of n. This is the conjugate. And multiply also here by the same number, which is square root of n plus 1 minus square root of n. So it's equal to, here just square root of n plus 1 minus square root of n, and in the denominator we will have a special product which is square root of n plus 1 squared minus square root of n squared. And this is of course equal to, it's equal to here square root of n plus 1 minus square root of n over n plus 1, this term, minus n. Square root of n plus 1 squared is n plus 1, square root of n squared is n. And here you see n will cancel, and we will have square root of n plus 1 minus square root of n over 1, which is just over 1. Here n cancels with n, we will just have 1. And this number over 1 is just square root of n plus 1 minus square root of n. So we have written our term as a difference like this. So this first one will be square root, here n is equal to 1, square root of 2 minus square root of 1. And the second one, the same rule, square root of 3 minus square root of 2. Here n is equal to 2 plus here square root of 4 minus square root of 3. And of course here square root of 99 minus square root of 98. And finally square root of 100 minus square root of 99. And here you see the same. There are all the terms will cancel except this one and this one. So here you see this one will cancel with the first one, and this one with the other one, this one with the next one, and also this one will cancel with this one, and this one will cancel with the previous one. So the remaining will just be square root of 100 minus square root of 1. Square root of 100 minus square root of 1, which is of course square root of 110 minus 1, and of course it's equal to 9. And of course this concludes our problem.